In this video, I'm going to show you how to build health checks for your API and any external services that you might be using. I'm also going to show you how to monitor the health of your system, and I'm going to explain how this can be used to improve the reliability of your application. The Run Tracker API that I'm building here has a few external dependencies. If I open up the Docker Compose file, you can see I have a database which is running PostgreSQL. I also have a Seek instance and a Redis instance to implement caching. All of these are external services that can affect the health of my system. If I open up Docker Desktop, you can see that all of my services are running successfully. But how can we confirm at any point if the status of our API is healthy? Well, this is where health checks come in, and ASP.NET Core has built-in support for running health checks. Here's what you need to get started. So first of all, I'm going to register the required services. So I'll say builder services add health checks. The next thing I need to do is to add an endpoint that we're going to query to get the API health status. So for this, I'm going to say map health checks, and then we need to provide the route where this endpoint will live. The most common approach is just exposing a health endpoint, and then when you query this on your API, it's going to return the health status. So let's go ahead and try this out. If I send a GET request to the health endpoint, we're going to get back a response, and it's just going to say that our API is healthy. If we send this request a few more times, nothing changes because our API is still functioning. However, this doesn't take into account the external services that we have. So let's see how we can improve on this. I'm going to move the registration of the health check services into my infrastructure project. Unfortunately, if I try to say services add health checks, you'll see that this method doesn't exist because I don't have the respective NuGet package. So let's look for health checks in the NuGet browser, and I want to install the Microsoft Extensions Diagnostics Health Checks library. So let's go ahead and install that, and now I can actually register my health check services, and I can implement a custom health check. So let's create a health folder inside of my infrastructure project, and I'm going to add a health check inside. So let's call this the database health check, and I'm going to implement this custom health check on my own. So I have to implement the iHealthCheck interface, which only exposes one method. This is an asynchronous method called checkHealthAsync. The simplest way to achieve this is to just open up a connection to your database and just run some simple query. So I'm going to inject a database connection factory, and I'm going to use this factory to create a new database connection instance. So let's call this the connection, and I'm going to obtain an instance by saying database connection factory open connection. Now I can execute a simple asynchronous query. Let's call execute scalar async, and I just want to say select one and return this value from the database if it is running. If this query completes, we're going to return a new health check result, and I want to say that this is a healthy response. However, this could throw an exception if the database is down, so let's add it into a try-catch statement, and when we have access to the exception, let's use it to return an unhealthy response. So I'll say health check result, unhealthy, and then you can pass in this exception to the exception argument, where it's going to be used to add some more context as to why this health check failed. Now that we implemented our custom health check, let's register it so that it's actually running. So all we have to do is say add check and then specify our health check type. So this is going to be the database health check. Let's call it the custom SQL health check, and then you can specify what is the failure status. So I'm going to say that the failure status is unhealthy. So whenever our health check fails, this is what will be reported. So let's start the API again and see how our health endpoint is behaving now. If I call the health endpoint again, you'll see that it's still returning the healthy response. However, if I go ahead and stop the database container that is running inside of our Docker desktop and rerun the health check, we're going to get an unhealthy response. This is because our custom health check is failing. And I can show you that this is the case by placing a breakpoint here and then sending the request to our health endpoint one more time. And you can see that we hit the breakpoint inside of our custom health check. So we open up a database connection, and unfortunately, this is going to throw an exception because the database isn't running. And now I'm going to return an unhealthy response containing the exception details. So let's go ahead and return this, and we get a 503 service unavailable response and an unhealthy API status. So why are health checks useful in the first place? Well, they allow you to monitor the status of your system and any dependent downstream services, and then you can use this information to implement failover scenarios for your application. If we detect that our API is unhealthy, we can decide to spin up a new API instance to replace the one that is no longer functioning, and this allows us to achieve better reliability for our system. Now, implementing custom health checks for all the services that you're depending on is really cumbersome. However, if you query for NuGet packages containing the word health checks, you're going to run into a lot of open source health checks that are available for you to use. So here's a health check for SQL Server. There's also a health check for Redis that I'm actually going to use. So let's go ahead and install it. I'm going to use this to verify the health of my Redis service. I'm also going to install the ASP.NET Core Health Checks MPG SQL library to test the status of my database. And if you don't want to test the database directly, you can use your database context if you are using EF Core. So I'm going to show you how to use this one as well. Other than the libraries that I'm going to use, there are many more, such as the RabbitMQ Health Check, Azure Storage, Kafka, Elasticsearch, and so on. So let's go back to our health check registration, and here's how to add the custom health checks that we just installed. So I can say add MPG SQL, and I just need to provide a connection string. I already have a database connection string available from registering EF Core previously in this method. Let's also add a health check for Redis, and I'm going to pass in the Redis connection string. And for the EF Core health check, you need to say add database context check, and you can make this a generic method and specify your database context. So now I'm running my custom health check alongside the pre-built health checks for the database, Redis, and my EF Core database context. However, the response that I'm getting from the health endpoint doesn't really tell me what went wrong. But there is a way how we can improve this, so let me show you how I'm going to do this. In our program file, where we are mapping the health check endpoint, the second argument is an instance of the health check options. So if I create a new health check options instance, I can provide a value for the response writer property. One more thing I'll need is another NuGet package. So let me go ahead and look for health checks. And the NuGet package that I'm looking for is ASP.NET Core Health Checks UI Client. This library contains a response writer that's going to improve the readability of our health endpoint response. What I need to specify here is UI response writer, and then pass in the write health check UI response method. And now I'm going to show you how this changes the response of the health endpoint to make it much more readable. If I call the health endpoint again, we're going to get back a healthy response, except this time the response is a JSON object, and it contains a lot of information. For example, how long the health checks took to execute, and it contains a collection of entries of the individual health checks that we have running. So if we expand this, you can see that we have our custom health check that's running the select one query. Here's the MPG SQL health check that we installed using a library, then the Redis health check that we added for checking the Redis instance, and then there's the EF Core check. It gets the name of the database context that you specify unless you provide a custom name for the health check. Let's go ahead and stop the Redis instance and rerun this query again. And you will see that it's taking a bit of time because the connection to the Redis instance is timing out, and we indeed get back an unhealthy response. And if I take a look at the Redis health check, you can see in the description that I'm getting the exception details. And the overall status of the health check is unhealthy. If I start the Redis container again and send my health check query, is going to go back to healthy because the Redis instance is now running. And the same is going to happen if I stop my database and then send the health query. You'll see that it's again taking some time to respond, and this time the free health checks that are all using the database are going to fail. So this will be the custom SQL health check, the MPG SQL health check, and the EF Core health check. And of course, if I turn the database back on and resend this query, we get back a healthy response. Now you can hopefully see how we can use this information to monitor the health of our system and any services that we are depending on. You can connect this to your monitoring tool that can detect when your database is down or the Redis instance is unavailable, and the monitoring system can start sending alerts to monitor you that something went wrong. You can also try to implement some failover scenarios, such as restarting the services that are down. Otherwise, you'll have to do a manual intervention. My general recommendation when it comes to health checks is to not implement your custom health checks unless you absolutely need to, because most of the time, if you want to implement a health check, somebody already built it and there's a NuGet package that you can use. So for example, I will remove the custom database health check and just use the MPG SQL one or the database context one. The database context check is helpful if you want to switch database providers. So right now I'm using PostgreSQL, but if I wanted to switch to SQL Server, this health check would continue functioning. However, I prefer using these simple health checks because they are more reliable and faster. If I take a look at the source code of this health check, you'll see that the health query is just select one, like I showed you in my custom health check. However, you do have the option to change this if you wanted to. And if I scroll down and show you the actual health check, it's called MPG SQL health check, and you'll see that the implementation is very similar to what we did. So it's opening a database connection, running our custom query, and then returning the appropriate response. If I take a look at the Redis health check, you'll see that it's a bit more verbose because you need to use the connection multiplexer, which is exposed by the Stack Exchange Redis library. And then this is the body of the health check, which I won't dive into, but essentially is just going to verify that the Redis instance is available. If you are running your application behind the load balancer, you can use health checks to inform the load balancer which API instances are running and are available to serve requests. If you enjoyed this video, then make sure to smash the like and subscribe buttons, and until next time, stay awesome.